Hello everybody, welcome to Mrs. Baker's monster paper for the metals module 10. This is question 6. This question is about metal and metal oxides. Most metals have a high melting point. State one other physical properties that all metals have. Well, the easiest one to go for is metals are good conductors of heat and electricity. Actually, you've got a pick here. You could either put heat or electricity. Both are correct. You could also have gone for malleable, and that would be another one, and ductile. Iron often rusts. Name two substances other than iron that must be present for iron to rust. Well, of course, in order for iron to become iron oxide, or rust more specifically, is hydrated iron oxide. So it must be water to make the hydrated bit and oxygen to make the oxide bit. Iron can be obtained by heating iron 3 oxide with zinc powder. So we've got iron oxide, we add zinc. The zinc displaces the oxygen because zinc is more reactive, and we end up with the iron metal by itself. What can be deduced about the reactivity of zinc from this reaction? Well, we can deduce that zinc is more reactive than iron. The ionic equation for this reaction is shown. Identify the oxidizing agent in this reaction and explain your answer in terms of electron transfer. So the easiest way to sort out this question is to look at the oxidation states. So iron has gone from 3 plus to iron as nothing. That is a decrease in oxidation state. A decrease is reduction. By the same term, the zinc has gone from nothing to zinc 2 plus. That is an increase from 0 to 2 plus. Therefore, it must be oxidation. We know that oxidation is loss and reduction is gain. So in this case, we've determined what the oxidizing agent is, because if something has been reduced, it is the oxidizing agent. And if something has been oxidized, it is the reducing agent. So we know that we're just looking here at the iron. So the oxidizing agent is in fact the Fe3+. Don't write iron, because if you write iron, you're implying that the iron itself, the iron atoms are the oxidizing agent. You need to show that you know that the oxidizing agent is the Fe3+. And the explanation for that, in terms of electron transfer, is that the iron Fe3+ has gained electrons from the zinc atoms, and that's why it has acted as a oxidizing agent. So zinc is amphoteric. Describe two simple experiments that show that zinc oxide is amphoteric. Name the reagents you would use and describe the observations you would make. Well, we know that an amphoteric oxide acts as both an acid and a base. If you offer an amphoteric oxide an acid, it will behave as a base. If we offer it a base, it will behave as an acid. So we need any named acid. So in this case, we could say reagent 1 is hydrochloric acid. And in that case, we would get zinc oxide would dissolve, because any acid plus any base makes a salt and water. So the other name reagent, you would use, say, sodium hydroxide, and the observation would be exactly the same. The zinc oxide would dissolve. It's the same observation, but you would have to use one known acid and one known base. The only other amphoteric oxide that you need to know about is aluminium oxide, and if they'd have chosen aluminium oxide, in this case, the answer would have been exactly the same.